everyone, welcome to the final episode of the Microservices March Lab experience here on DevCentral Connects. Thank you, Boo, for stepping in last week for me as I was out on an audition run with my son up in Iowa. And I live here in the Midwest in the St. Louis area. And so, Iowa, at least, to the edge of Iowa is only a few hours away. So we drove it. And tomorrow I head east, a little bit farther of a drive to Pennsylvania for another audition with my son. And so it's that season, right? He graduated last year, took a gap year, and is auditioning for different things for what might be the future of his life. And so I get to do the dad taxi all over America, which is fun. Enjoy doing road trips with my boy. So, but today I'm here. We're going to do this Microservices March Lab, and I'm excited about it. If you haven't registered, it's not too late. You can get access to all the weeks of content. And also just for the community standpoint, you can go to nginxcommunity.slack.com, get registered. And the Slack channel specific for this is Microservices-March. However, if you are using nginx in any capacity already or want to join the community, and we're all over there. I'm in there occasionally, but the nginx team is on top of it. They're very active there, so hang out there and connect. And also next Tuesday at DevCentral Connects with Boo Lamb. He is your weekly host there, and I get to join him again. So I haven't been on Tuesdays other than a fanboy in the audience for a while. So I'm excited to join Boo on Tuesday, and that'll be a lot of fun. And last week when you guys did the lab, you were in lab 3, and I guess there was some feedback that about the Azure account requirements and all that. So if you weren't able to do the lab, you weren't able to get into your Azure account or a Azure account and Azure account and maybe I English well. I've only been at it for 49 years. So, but there was a little bit of feedback. And so if you are working your way towards your Microservices March badge, the lab 3 has been excluded from that. So if you weren't able to complete that lab, have no fear. Completing lab 4 plus the other webinar stuff, you'll get your badge. So fear not. And today we're actually going to get into lab 4, which is about open telemetry and understanding your microservices. So we'll get that lab going here. And while that's booting up, I guess some things will be booting up or setting up. But while that's kicking off, estimated time is 2 minutes and 37 seconds. So while that's doing its thing, we can talk about observability. But let's first reach out to Jose. Welcome back. Hey, yep. Always appreciate that that weekly look at your cute kid. I just had grandchild number 3 on Thursday, welcomed to the world by my daughter and her husband, and so I have new pictures of all my grandbabies, and so I love seeing family here on the DevCentral community family. So welcome to the show, Jose. And Boo is out there in the audience. Boo, how are you? Boo and his awesome helmet. One day I hope to have a helmet as awesome as Boo's there. Although it'd look weird, me wearing that helmet in the very flat concrete and paved roads of O'Fallon, Illinois. And so talking about observability and telemetry, why is observability so important? And so of course, what is it? Let's do the what is it first. And when you're talking about what are you observing, right? And so if you go to traditional monolithic architectures of the past, it was fairly easy for the to see what was going on, because you had, maybe you had your front door, you had your database, all those services are kind of tightly bound and integrated. And so you didn't really have to have too much observation outside of those tightly coupled services. However, even in a monolithic architectures, those application deployments kind of get away from you. And before you know it, you have 65,000 applications running in your environment. You have no idea what's going on. And that's problematic in a lot of ways. One, you don't know when your services are going down, but also like these supply chain attacks and all that. And you don't even know what you have running in your environment and what you're vulnerable to. That's problematic too. So, you look at that, but then you come forward into these, these modern architectures. Failed to fetch. That's not good. Let's try that again. Let's see. Let me stop and maybe I can restart it. Let's give that another try. And so you come into the modern architectures where you have services that are here, there, and everywhere, right? You have services that are going north, south, east, west, and they're very loosely coupled, and they might not even be in the same place. You've got service A running over here in data center B, and then you have service C running in 18 data centers globally. You have compute running at all different levels of the connection between a client and you or your servers, and how are you going to bring all that back in house? Not just from a collection standpoint, because that's part of it, right? When you're observing, you've got metrics where you're detecting things, you've got your tracing where you're troubleshooting, and then you've got your logs that are going to show your root cause. And so, you need to bring all of that stuff together. And it's not just about collection, right? Open telemetry observation, right, is focusing on the analytics of it all. It's not just, hey, let's throw it all in a Elasticsearch or a Splunk bucket, and then, hey, I have all that I can look at down the road for forensics or whatever. It's not just about collecting it. It's about bringing all that forward to figure out what's really going on in your environment. And so that's what we're going to do today. And if you have not gone and watched the webinar for this week, it's good. Dave McAllister, who's a friend of the show, he's been on to talk to us about WebAssembly stuff. And he is one of the speakers in the webinar session this week. And so go check that out. And while I'm waiting for this to get going, we could just kind of go through what we're going to do today and our challenges that are in front of us. I kind of feel like in these challenge setups that it's kind of like working through a Mario level, right? Who here? Raise your hand. I can't see your hands, but maybe drop a comment. What, like, from video game world in your past, maybe not the most modern ones, but go back, I guess, my childhood and some of the early Super Mario stuff, the change in a game from like Pong and Snake and all those that are pretty much once you're dead, going to a concept of checkpoints in a level that allows you to make some progress towards the flag, but not get all the way there, so you don't have to loop out all the way back to the beginning. I guess the brain science behind that is giving me a little cookie along the way to say, you almost got this, hey, you got this. And so it's that gamification built into games like that. But I digress. How is all of that for you? In what game was that for you? What game brought you into the fold of not getting frustrated and throwing the controller across the floor? And so that's right. They don't understand them not having save points. That's right. Because I don't know if you one of the games that my wife beat on Atari was the what was the game you fell in? I'm drawing a blank, but it's you're leaping over alligators and through the jungle, and I can't believe I am losing that title right now. But anyway, she beat that game, and but that's like one of those you got to play for. Pitfall, thank you. Boo saved me there. Pitfall, absolutely. And so thank you. They're all coming in now. Thank you, Tony. But yeah, Pitfall was that game. And I always went left. I don't know if you went backwards or forward. I felt like I had a better chance of getting over those alligators going left. And you could go either way. But I never beat that game. I don't have the coordination skills between my hands and eyes to be successful with stuff like that. I played tennis in high school, but I played for a very small school in Missouri, which, they're like, hey, not only we're not going to cut you, but we're going to make you the number 3 seed, and I can barely toss a ball up in the air. So, and I enjoyed playing, love tennis, but my hand-eye coordination does not allow me to have much success against anybody with a little bit of skill. But that's okay. I enjoy doing things even if I'm not good at it, except golf. Golf's one of those things that back in the .com world, let's get this started, in the .com world, that before the .com crash, everybody was throwing money at you left and right for, hey, buy our stuff. And they'd like do ridiculous things. We had one company like took us on a ski trip at the startup I was working on. But golf was one of those things, and I'm not good at golf. And I found that I really enjoyed it until the .com crash, and then nobody was taking me out to play golf, and I had to pay for it. And then I get so mad. It's like, why am I paying like $30 to be angry for 4 hours? And so I sold my clubs. I haven't played golf except for Tony, my fearless leader, and he hates being called that. My fearless leader took us to play golf, and he paid for it, so it was all good, and I had fun. So anyway, I digress. And Tony is the worst Atari pit to fall in. Yes, the ET game. There's a documentary out there on the ET game. If you haven't seen it, I don't know what the documentary is called, but it was really good. It was interesting to see the world of video game development back then, where it was like, hey, we've got this idea, we've got to get it out the door. You have like 90 hours, make it happen. You're like, what? And I remember paying for that game. It was like $60 even back then in the early 80s, which was a lot of stinking money. And it was such a bad game. And Aubrey, my Atari pit was Mountain King. I don't know that one. Yeah, the memory constraints. And I did have, like, my uncle, I think he had a buddy who had an early hack or whatever. So he had a little plug-in that went into the Atari cartridge. So, but the top of it was removed, and you could then seat different chips onto that. I guess friends flashed for him and stuff. So he did not pay for very many games. He got them on the dark web of the early 1980s. So which wasn't a web at all. Anyway, let's get started. All right. So in this tutorial, we're going to focus on tracing the operations of a microservices app with OpenTelemetry. In the 4 challenges in this tutorial, you'll learn how to track a request through your system and answer questions about your microservices. So we're going to set up the basic instrumentation of OpenTelemetry, and then we're going to set up trace visualizations for all the services and learn to read OpenTelemetry traces and optimize instrumentation based on our trace readings. So our first challenge time limit is 10 minutes. All right, let's do that then. Let's start here. And these challenges illustrate our recommended process when setting up tracing for the first time. The steps are: understand the system as well as the particular operation you're instrumenting, decide what you need to know from the running system, instrument the system natively, and evaluate whether the instrumentation helps you answer your questions. Tweak the information that is reported to allow you to more quickly answer those questions. So it's like a standard troubleshooting process, no matter what environment you're troubleshooting in. You want to get the signal out of all the noise, right? So tweaking and tuning is part of the process, no matter what you're in, whether it's diagnosing a carburetor on your car or microservices in a modern architecture. All right. So following this process, you should first understand the system overall. Does it allow me to bring that up? Okay, good deal. So we got nginx and a messenger, RabbitMQ. So we got a messaging service, some kind of a messaging broker here. And we're going to process we got a database here. We got the notifier database, the messenger database. Okay. Now it's really Jaeger. Okay, so we got OpenTelemetry coming at Jaeger from all these places, from nginx, from the messenger queues, and from messenger queues. So and notifier. Okay. All right. The messenger service is a simple chat API with message storage capabilities. The notifier service is a listener that triggers events to alert users based on their preferences. Our infrastructure is nginx open source, an entry point to the messenger service with the system at large. RabbitMQ, okay. Our popular open source message broker that enables services to communicate asynchronously. And Jaeger is an open source end-to-end distributed tracing system for collecting and visualizing telemetry from components of the system that produce it. All right, in this lab, you will use OpenTelemetry to trace a request through these components. All right. And the next in the process is understanding the particular operation. In this case, it is the case where one user sends a new message to another. Okay. So our workflow here is we get a messenger, comes back to the database. That message comes through the message broker and is sent over to the notifier database. And then that notifier sends that notification out. Okay. Pretty straightforward. The flow breaks down like this. The nginx reverse process intercepts the message and forwards it to one of many instances of the messenger service. The messenger service writes the new message to its database. The messenger service produces an event on a RabbitMQ message queue called chat queue to indicate that a message was sent. The event is generic and has no specific target. At the same time, the messenger service returns a response to the sender reporting that the message was sent successfully, and the notifier service notifies the new event on the chat queue and consumes it. Then the notifier service checks its database for the notification preference of the recipient of the new message, and then it uses that recipient's preferred method to send one or many notifications. And in this tutorial, it's SMS and email. All right. And the next step in the process is to set goals. In this lab, you will try to accomplish 3 goals. All right. Understand all the steps a request goes through during the new message flow. Have confidence that the flow is executing end-to-end within 5 seconds under normal conditions. See how long it takes the notifier service to begin processing the event. And see if excessive delay might mean the notifier service is having trouble reading from the event queue and events are backing up. All right. A lot of setup here, but we'll get to do something here in a second, I promise. Tracing and traces, an account of the journey of a request of an action as it moves through all the nodes of a distributed system. And then a span is a record within a trace of an operation and its associated metadata. Traces are made up of many nested spans. Okay, so the trace is the account, and then the span is a record within that account. Or rather an accounting, not like a user account, if I was being confusing there. All right, so in this challenge, you will set up the most basic OTel instrumentation in the messenger service using the Node.js SDK. In challenge 2, you will instrument for the other parts of the system and start sending data to a visualization tool. Both of these challenges are the instrument the system natively. Naively, we don't want to do that. We don't want to be naive here. We want to be native. Silly typo. It happens. All right. So here, let's do something. We're going to use tab messenger, okay, which is where we are. And we're going to install the OpenTelemetry libraries, and I'm going to copy and paste. I've learned my lesson. And it's doing its thing. All right, so those 2 libraries provide the following functionality: generation and export of OpenTelemetry data. OpenTelemetry is OTel, and so we'll just say OTel to save me some. I think I'm having a little voice thing here this morning, so I'll save just a little bit of talking. And then the other one is automatic setup with default configuration of the most common Node.js instrumentations. Okay. Note it's a quirk of OpenTelemetry that its Java SDKs are broken up into very, very small pieces. So you will be installing a few more packages just for the basic example in this tutorial. To understand which packages you might need to accomplish any instrumentation task beyond these covered in the tutorial, peruse the very good OTel Getting Started guide and look through their GitHub repository. This isn't actually a bad thing because storage costs and the less that you have to store, the better. And so small packages are good packages, right? Okay. We're going to create a file. So we're using the tab code editor. Maybe we do that here first. Okay. I assume we're going to be in this particular folder, MJS. Okay. Now, if we go over to our code editor, and I'm looking for tracing. Add the following. Oh, app is where it is. There it is. Took me a second there. And we're going to create that. And okay. So we're going to go through that. Imports the required functions on objects from the OTel SDK. So we're going to open that. We're going to do an import on that. And then creates a new instance of the Node SDK and configures it to send spans to the console. Okay. And use the auto instrumenter as the base set of instrumentation. Okay. So instrumentation and tracing, that makes sense. And then in the tutorial, the relevant ones are OpenTelemetry, instrument. I'm going to bring this out just a little bit. Okay. OpenTelemetry, instrumentation for the Postgres database library. And then instrumentation-express for the Node.js Express framework. And then instrumentation-amqplib for the Rabbit. Okay. First two kind of make sense. That last one, I don't get the, this does not look like RabbitMQ. Although I will say from a Rabbit perspective, Tony does trivia with us when we do our team meetings. And I learned that a baby rabbit is a kit. So this is, not relevant to the lab, but hey, if you do trivia ever, another little nugget for your trivia knowledge. Maybe you already knew that, but I did not have my baby rabbit nomenclature down. So, all right. So let's save our file. I don't see a save. So hopefully that saves on its own. It doesn't look like I can save. So maybe just, all right. Make sure you save the file in the text editor before it can, okay? How do I do that? Can't just do a Command S. I do, hopefully. All right. So number 3, start the SDK. So we want to go back to the messenger and start the messenger service. Let's give that a try. Okay, that's encouraging. All right, after a moment, a lot of output related to tracing starts appearing in the console, which is your terminal. Okay. So we see a bunch of trace IDs coming in. All right, so that's an example of one. All right, one of the microservices can produce OpenTelemetry traces. All right, the traces are just going to the console for now, but the basic setup is complete, and you did not have to touch the main application code. All right, congratulations, you have completed this challenge. Woohoo! I think we need some clapping there. Let's give ourselves a hand here. Woo! We finished. All right, so we'll check. Are we running? I guess I should have checked before I gave myself a clap. All right. Loading the next challenge here. All right, challenge 2. Set up OTel instrumentation and trace visualization for all the services. In this challenge, you will instrument the other elements of the system and send the traces to Jaeger for easy viewing. All right, good enough. Let's bring that out a little bit. Okay. So we're going to set up OTel instrumentation and trace visualization. In challenge 1, you sent traces from the messenger service. In this challenge, you'll instrument the other elements of the system and send the traces to Jaeger, an open source end-to-end distribution tracing framework with a built-in web-based user interface for viewing the spans and other tracing data. So we got 12 minutes for this one. All right. In this challenge, you will instrument the messenger service, the notifier service, and nginx. Okay. This is the third step of the instrumentation process you learned in challenge 1. Instrument the system in a basic way. It's important to do this after you understand your goals for adding instrumentation. All right. So again, if we review the architecture diagram, we're going to instrument all of that and send it to Jaeger. So let's do this. Part 1 is we're going to use the tab messenger again, which is where we are. And we're going to cd to messenger app. Okay. Then we're going to install the OLTP or OTLP. I'm going to copy and paste. Oh, see, I didn't copy on the CD there. I'm pretty safe with the changing directories. I think I can handle that one. But all right. So 32 packages are okay. The exporter trace library exports trace information via HTTP in OpenTelemetry LP. I'm not sure what the LP stands for. I'm going to have to look that up. OpenTelemetry data. It's used when sending telemetry to an OpenTelemetry collector, Jaeger in this tutorial. See, I thought I'd get through the whole thing without saying Jaeger, but I'm assuming it's Jaeger. Okay. We're going to go to the code editor window. And we're going to change the contents of this file a little bit. So before we change them, let me just put them down here to see what we're changing here. So we've got our instrumentation, but we've added the OTLP trace exporter. And then we have changed, we just changed our trace exporter from a console span to export it instead of just send it to console. The rest of it looks the same. Okay, so we can delete that. Command S, in case I needed that. All right. In the above code, we have changed the value. Okay, we covered that. So we're going to use the tab messenger again. And then we're going to run the service again. All right, so use the tab request runner. I assume that's request runner. All right, so curl -x. Yeah, oh, here I am. I'm typing again. Somebody needs to call me out. All right, so we got an OK there. Why wait? Node.js will produce a lot of file system access spans. Waiting short time after starting the app helps us see our main traces without distractions. All right, now you can take a look at the traces produced by this simple health check request in the Jaeger UI. So let's go over to Jaeger. All right, and maybe I need to minimize this a little bit. Minimize that. What's it asking me to do here? Oh, lost my place here. Give me a second. Refresh the Jaeger UI to see the traces. I don't know how to get to that refresh there. Just tap that. Click the search in the title bar. Okay, so I can't get to whatever that little refresh is. But that's okay. We'll move on to step 7 and see. Okay. Select a service from the drop-down menu. It will start with unknown service. Click the Find Traces button. Okay, we have 20 traces. And click a trace in the right side of the window to display a list of its spans. Okay, oh, that's cool. Each span describes the operation, sometimes spanning multiple services that ran as part of that trace. Okay, so if I minimize, send that back a little bit. All right. Microseconds. That's fancy. You don't get that kind of timing when you're sending syslogs, do you? All right. Each span describes the operation, sometimes spanning multiple services that ran as part of the trace. Okay. It's great that you can see the traces in the web UI, but the name of the service as exported is not meaningful. You will fix this now. All right. So we want to stop the application in Messenger. Okay. Install 2 packages that will help you define some things about the service. So let me copy those. Bring this back out so I can see what they are. Okay, semantic conventions and resources. Okay. All right, they provide the following functionality. Defines the standard attributes for traces as defined in the OTel specification, and defines an object that represents the source generating the OTel data, in this lab, the messenger service. Okay, now you will use these 2 libraries in the open telemetry configuration script. All right, so we're going to modify the script again. All right, and again, let's just paste that and look. Oh, yep, a lot of changes in that one. So the top 3, no change there. We are having these 2 new lines, the resource and the semantics, and we have a new variable that we then reference in our Node SDK. So, all right, let me bring that up, and then we can kind of walk through the details in the script. All right, okay. All right. So here, the changes in the above code, importing the 2 new libraries to give us resource and semantic resource attributes. Creating a new resource and setting the service name to messenger, and then passing the resource to the Node SDK constructor to make open telemetry, add that information to all traces. Now you will test out the changes. Start the application again. Okay, let's do that. And nope, that's not what I needed to do. Okay. So we'll go back to request runner. Do our 10-second countdown here. I think we're there. Okay. Now, use tab Jaeger, the thing that I can't get to. Oh, maybe it's that. Okay. Yep, that's just a little smaller. If I'd have brought that up, I would have seen that a little better. My bad. So click on the services drop down again, and you should see a new service called Messenger. And we do. And you can select it and click Find Traces. And we indeed have our service recognized there. Good deal. Clicking on that trace will show you that the spans under that trace are also identified as Messenger. Okay, that's good to know. A query, express init, CORS middleware, JSON parser. Okay, cool. Now that you have the messenger service sending traces and labeling those, next you'll set up the other services in the same way. And when you're finished, you will have the two microservices as well as the nginx reverse proxy producing properly tagged traces to Jaeger. All right, so let's go to the notifier app in Messenger. Oh, wait, sorry, notifier. We need to cd into notifier app. And it looks like we're not building this one out because it's more of the same. Okay. And then let's go back to request runner. See what we got. Okay, we're okay there. Now we go back to Jaeger, reload the page. Now we should also have a notifier. If we go find traces, good deal. We should see a trace called notifier get health. Oh, don't see that one yet. Let me refresh and try again. There we go. All right. Clicking on a trace will show you that all the spans under the trace are also identified as notifier. Good deal. So now let's get set up with nginx. All right. So go to the root directory of the messenger directory. Okay. I wonder if it, wait, use tab. Okay. cd messenger. Create a directory to hold the configuration files. Let me just go ahead and copy and paste. All right. Now going over to code editor. Add to the messenger Docker file. I'm going to bring up an nginx. Let's see, code editor, Docker file, messenger. Load balancer Docker file. Okay. And we're going to install a bunch of open telemetry stuff. Okay. Then add to the messenger load balancer.conf. Messenger load dash balancer. Well, nginx, sorry. It's having trouble reading there. Okay. So we'll put our config in here. And the upstream messenger, we're going to listen on that part and proxy that. Okay, sets up an upstream called messenger that represents the group of messenger service instances, listening for HTTP requests on 8085 for all incoming requests for paths starting with root to the messenger upstream. Note this is pretty close to the actual configuration of nginx as a reverse proxy and load balancer. The only major difference is that the argument to the server directive in the upstream block is usually a domain name or IP address rather than localhost. All right. So now we've got open telemetry module.conf. The above is the config that is specific to the third-party open telemetry module for nginx. It mostly does the same thing as the JavaScript configuration file you made earlier. It labels the traces and tells the process where to send the traces. All right. So let's save those. Okay. And now let's go to tab nginx lb. And let's make sure we build that image. and then we will run it. Okay. So it's running, but I have an error. Okay, maybe. Okay. So let's check to see if we're running okay. Okay. And of course, in that check, you saw those requests coming in there. All right. So now our third challenge here. Let's read over a full distributed trace across 2 microservices and other infrastructure service. Evaluate the trace in terms of your telemetry goals. So we're going to understand the steps a request goes through during the new message flow. Have confidence that the flow is executing end-to-end within 5 seconds under normal conditions. See how long it takes the notifier service to begin processing the event dispatched by the messenger service. Okay. Meaning we want to avoid these excessive delays. All right, let's do this. All right. All right, so we want to, yeah, we saw that. So let's get started. There will be a short quiz after this section. Uh-oh. All right, so we want to make sure that all the services and the load balancer are up from the previous challenger. So we want to go to Messenger, and we want to CD into Messenger and get that running. And then in the Notifier tab, let's go over there. All right, so we got services running. And then let's go to the nginx and get the container running. All right, so we do have running services now. So in this part, you will send some sample requests, which we use to evaluate whether the traces solve the telemetry goals. Wait about 10 seconds after completing part 1. Why? Yep, we got that earlier. All right, so use the request runner. Send a request that creates a conversation between 2 users. Okay, so what tab? Request runner. Okay. So we're going to go over here and we're going to do a post that is going to communicate from participant 1 to 2, or creates the conversation anyway. Okay. And then we're going to send 2 requests back and forth. So two posts, 1 to 2 and 2 to 1. All right. So, all right. Optional, you can check the notifier tab to see the notifications that were sent out. And we do see that. And part 3. This section is optional, but you can use it for reference. Okay. So the new message flow, again, we talked about that at the beginning before we started doing anything. And it's going to go through, and then the broker is going to handle that. And then that is going to go out from a notification perspective and go out. So message sent and stored, then message notified and sent, pretty much. Breaking down those 6 steps into 2. Message sent, message then forwarded through the broker. Okay. We talked about that before. We can skip through that. Now, number 4, we're going to read the trace. Reload the tab containing the Jaeger UI. So let's go over here. All right. So find the trace to read. From the services dropdown, select the messenger LB. And then find a trace called messenger LB conversations 1. Okay. So it looks like we had 2 of those. All right. you should see a trace that looks something like this. And we do. Okay. Oh, so we're in this particular one. Okay. Click around and explore a little bit. Okay, so let's do that. Let me slide this out a little bit, just so we can kind of see what's going on here. Okay, so we posted a conversation. That was our curl once we created the conversation. And then let's see, we have a middleware query, CORS middleware, expressInit, then JSON parser. Okay, this is like actually seriously tracing what's going on each individual component of this. And then, okay, wow. So that's way more detail than I was expecting. I was expecting just kind of, more request flow rather than actually into the details of what's going on each process. So that's pretty interesting. We even have a DNS lookup in here. So this is getting hairy. Okay. So let's see. Then before moving on, consider how the information in the trace supports your goals for instrumentation. So the goal here is one of the goals, if I'm remembering correctly, is like we want no excessive timing, because we want to make sure, make that small. Let me go back. Just want to look at. All right. So this particular conversation is 75 milliseconds. That's doable if we're under the 7 or the 5 seconds or whatever, and all those are pretty short. But you see, you have quite a bit of difference between the conversation setup and a message sending setup. 75 milliseconds and 215 milliseconds. Both of those are very short time frames, but on a fairly light, small system, the difference between those, that's quite a bit of variance for something so small. And I don't know if they have a delay engine in there for this, or if we'll hit that here in a second. Okay, so what information is missing? What information is not relevant? That is a good question. Let me go back. Nope. All right, let's move on. But definitely the timing is, I'm forgetting our goals. So if you are remembering our goals, let me know what the goals were. The timing is the one I remembered, but we'll look into on part 4 here. All right. In this part, you examine the nginx trace to see if the telemetry goals are satisfied. Okay, since the current nginx configuration is very simple, the child spans are not very interesting, and simply show the time taken for each step in the nginx request processing lifecycle. Click the very top span labeled messenger LB. Okay. And this span helps you understand the request started in the right place. Under tags, look for the following attributes: HTTP method. We can pull that down. Okay. HTTP method post in REST terms creation. HTTP status code was a 201, indicating successful creation. HTTP target field is the conversations 1/messages. Taken together, these 3 pieces of information combined to say a post request was sent to conversations 1 messages, and the response was 201 created successfully. This corresponds to steps 1 and 4A in the architecture and user flow. Under process, the web engine name shows that the nginx process. Okay, let's go down there. The web engine name field shows that this is the nginx portion of the request. This information satisfies the goal because you can see that the nginx reverse proxy was part of the flow. All right, so that was goal number 1. See all the steps in a request undergoes in the message flow. Okay. Goal 2, verify that the flow executes within 5 seconds. All right, for goal 2, take a look at the very last span in the message LB. Is that the last one? Okay. You should see start time, duration 48 microseconds, start time, okay, and duration. All right. And step 4, at the start time and duration together to find out how long the request spent in the nginx portion of the flow. This number should be a very short period of time. All right, so add the start time and duration together. All right, so that would be a microsecond is, point, way down there. It's like the sixth location. So, effectively still 1.02 milliseconds with the tiny little hair. All right, this information satisfies the goal because you can see that the nginx operation took way less than 5 seconds. If there is a very slow operation in the flow, it must be happening later on. See how long it takes the notifier service to read the event dispatched by the messenger service. The nginx proxy layer doesn't include any information about this, so you can move on to the messenger spans. Okay. All right. So let's go to the messenger spans, find traces. Okay, so we've got our messenger spans in there. Okay, click the very top trace that is labeled messenger. It should be called post. I don't see. Let me refresh that. Service messenger. Find traces. What am I looking for here? Still should be under the messenger LB. Okay, let me go back. And that was for, let's see that one more time. Messenger LB. Okay. It should be called post conversations, conversation ID. Okay. And click on that. Under tags, we're looking for HTTP method. It was a post. The route was conversations, okay. And then HTTP target field is okay. So that satisfies goal 1 because that maps to what we saw on nginx. And then goal 2, we're going to look at our let's go down to the process side. No? Okay. Step 4, add the start of the last span, then subtract the start time of the first span. This equation provides the total time the request spent in the messenger service. I'm looking for that. Okay, there we go. Duration, it's kind of jumbling on top of each other. Let me bring that back a little bit. Okay, so duration and start time. So let's see, add the start time and duration of the last span, then subtract the start time of the first span. This equation provides the total time the request spent in the messenger service. All right. This information satisfies the goal because you can see that the nginx operation didn't take anywhere close to 5 seconds. If there's a very slow, it must be happening later on. See how long it takes the notifier service to read the event. Okay. Like the nginx spans, the messenger spans don't include this information, so you can move on to the notifier spans. All right. In this part, you'll examine the notifier trace. Okay. To see. So let's go. Okay. So then we can come down to notifier. And then if we open up chat queue process, okay, and we see our duration is 59 milliseconds. All right, confirms that the notifier service processed an event from the queue. PG pool .connect span shows that after processing the event, come down here, that made some sort of connection to its database. Okay, and you see that Postgres request there. This information is available from these spans only, partially fulfills the goal of understanding every step. You can see that the notifier service got to the point of consuming the event from the queue, but you don't know if the message notification sent by this service corresponds to the event dispatched by the messenger service, or the relevant message notifications were correctly sent to the recipient of the message. This indicates that you need to manually send the spans that show a notification being sent. All right. Look at the overall timing of the notifier service spans. Okay, you can see that the time spent in notifier is not even close to 5 minutes. However, because there are no spans that signal the end of the whole flow, you can't determine the total timing of this section of the flow or the overall completion time for the operation. Goal 3, see how long it takes the notifier service to read the event dispatched by the messenger service. Okay, so look at the messenger and notifier spans. You should see chat queue send and messenger. All right, so we should see. Okay. At the beginning of the chat queue process, okay, is unreasonably long. That doesn't look that long to me. Goal 3 is met because you know the notifier consumed an event after it was dispatched by the messenger service. Unlike goal 2, achieving this goal 3 doesn't require you know whether the event is processed fully or how long it looks. Okay. At the beginning, let me see, between the end of the chat queue send, unreasonably long is 2 minutes. Okay. All right. All right. Conclusions here. Looking at the trace, it is clear that you will need to manually create spans for the sending of notifications to satisfy your telemetry goals. You will do that in challenge 5. Challenge 4 is a quiz on the topics from challenge 3. Make sure you understand the conclusions portions of this challenge before you move it on. You read a distributed trace, and you applied a process to guide your understanding of the distributed trace between the different components. Congratulations, you have completed this challenge, and we are at the top of the hour. I will do the quiz here in a little bit, but I think we made it through. We made it through our setups here. So I will continue on in the lab later, but you know, I think this is a lot to take in. I don't know if you're following along or you're doing the lab along with me. But there's a lot to take in here because you know if you're not familiar with you know one building microservices, but then understanding all the telemetry behind it, it can be a bit much. And to be honest, I'm reading through here the first 2 labs I did, lab 1 and lab 2, made a lot of sense. I didn't have any hangups here. I'm not sure I fully grok what's going on in Jaeger because I'm more thinking about things that are happening on the flow level. There's a lot more detail in here to the actual tracing of what's going on in each component than I was prepared to see, and I'm amazed by that, and I'm intrigued by that. But you know, I won't sit here and say I understand it all, and so I have work to do there to fully grok this lab. I might walk through it a second or third time, and that's okay. And I think that you know, for all of you out there who are going through these labs for microservices, take your time. There's no hurry, and I know that they have timers on here, and if you time out in a particular section, it's no big deal. You can go back and do it again because understanding these things are important. And I think they even in this lab they're you know telling you, hey, make sure you understand these concepts before you move on. And so, that's homework for me, is to really grok the importance and significance of the tools that we're deploying here. And because one, that makes you more in tune with what's going on in your new architectures. And it's a different world than, for me, being a traditional network engineer and an operations technician and working in Wireshark, and you see stuff on the wire, and you're diving into protocols on the wire and all that, and you're figuring out those things, tracing applications and what's going on, and how those things are connecting and doing their things, is a different world for me. And so that's not going to be an overnight thing. It's going to take time. And I had a Wireshark instructor way back in the day. Actually, it wasn't Wireshark. It was a Network Instruments, whatever their sniffer is. And he said, if you're not in the packet captures 15 minutes a day, you'll lose it. And I think that's true of any kind of technology, because none of this stuff is like riding a bike, right? You might remember basics and all that, but you're not really gonna get into this and get detailed and stay detailed unless you're doing it on a consistent basis. So, that would be my advice to you, the community, as you do labs like this, is, don't one and done like Ron Popeil, set it and forget it. That doesn't work with what we do. And so get out there, get into this stuff, learn all the tools. And it doesn't have to be Jaeger, and it doesn't have to be Node and all that. Whatever tool is the right tool for your toolbox in your environment, just spend the time, learn it, learn all the nuances of all that. And I am excited that we got to do these labs together for Microservices March. It's been a lot of fun, and I look forward to next year doing a whole new round. That they do a great job putting these labs together and driving understanding in the environments that we work in. And open telemetry is certainly the next wave of observability. So whatever tools you use, make sure that is supported as an option. And so with that, I will bid you adieu, and I look forward to seeing you all on Tuesday morning at 8:30 a.m. Pacific with Boo. And until then, have a great weekend, and we'll see you out there in the community. Thank you.
Well, thanks for checking out that video. If you have any questions, leave a comment down below. While you're down there, hit the like button and subscribe if you haven't already. You might want to check out one of these videos over here. And if you haven't already, go check out community.f5.com. This is where all the DevCentral Connects hosts hang out, as well as the rest of the community. It's free to sign up, and we'll see you there.